Welcome children, welcome to another chemistry class. Today we are going to discuss some important questions from chapter 6, that is chemical thermodynamics. Thermodynamics is the topic today. Can we start? Ready? Yes. First question. Heat of combustion of carbon to carbon dioxide given. The heat involved upon formation of 35.2 gram CO2 from carbon and oxygen gas is 35.2 gram of CO2 from carbon and oxygen. So the point is very simple, right? You see this data given. This given is minus 393.5 kilojoule per mole. That means for 1 mole carbon dioxide, it is minus 393.5. 1 mole carbon dioxide means for 44 gram. For 44 gram, that is 1 mole, the heat released is this much. That is 393.5. Heat released means that is minus. Minus means released. Now the heat involved upon formation of 35.2 gram. Therefore 35.2 gram, how much is the data? That's all. That's all. So how to calculate? It is minus 393.5 into 35.2 divided by 44. That's it. So it will be very easy to see that 35, 44 less than 1. So this will be slightly less than that figure. So it will be minus 315. Option 3 should be the answer. Option 3 should be the answer, minus 315. No need of any calculation. 35 by 44 is slightly less than 1. So when you multiply minus 393.5 with a slightly less than 1 means slightly less than this figure. So only one choice available, option 3. Hope you understand. So for 1 mole carbon dioxide, the heat released is minus 393.5. 1 mole carbon dioxide means 44 gram. So for 44 gram, that is the heat. So for 35 gram, how much is the heat? That's it. Next question. For a sample of perfect gas, when its pressure is changed isothermally from P initial to P final, entropy change is given by entropy equation you might have seen, which is so derived. You see that you will get fourth choice as the correct answer. Starting from, this is the relation, delta S relation, that is integral initial to final condition dq by dt. You know, entropy, change in entropy is Q reversible by time. You have learnt. So delta S is equal to Q by T. You have learnt. Now if there is a two states given, for measurable change between two state, initial and final, you get that relation. And as the temperature remain constant, you get it like that. And Q reversible, when you substitute, this is the condition. That is, Q reversible will be work reversible minus work reversible. So it is nRT dV by V. So delta S is equal to 1 by T into, substituting here, integral initial to final nRT dV by V. And that is nRT tt gets cancels. You get nR log V final by V initial. This is an equation definitely you might have seen. Delta S is equal to nR log V final by V initial. Remember, that is volume. That is for volume. And here what we need to find out is in terms of pressure. So V final, V initial, there it becomes P initial, P final. That's all, because it is inversely related. So which choice? We will get fourth choice. Delta S is equal to NR log P initial by P final. I think it is clear, right? So this much derivation steps you can understand, and that in between steps may helpful in another type of formula type questions also. Okay. So here it is V final by V initial, and in pressure it will be P initial by P final. That's all. Next question. A gas allowed to expand in a well-insulated container. In a well-insulated container against a constant external pressure 2.5 atm from an initial volume of 2.5 liters to a final volume 4.5 liter. Change in internal energy delta U of the gas. That is what you need to find out. Change in internal energy according to first law of thermodynamics, you know, it is, what is the equation? Delta U is equal to Q plus W. Delta U is equal to Q plus W. So first law of thermodynamics commenting like that, here it is well insulated. What happens? Q equal to 0. So what is the condition? Delta U is equal to W. What is W? Minus P delta V. What is given? P is given, delta V is given. You get the answer in liter atm. We want in joules. How to convert liter atm to joules? You know that. So convert that. 5 liter atm. So it will be into 101.33 joules. So it will be 505 joules minus 505 joules. Option 3 is the correct answer. I think it is clear. So since it is a adiabatic condition, Q will be 0. Okay, next. Fourth question. For a given reaction, delta H given, delta S given, the reaction is spontaneous at. The reaction is spontaneous at. So what do we apply? Gibbs equation. Delta G is equal to delta H minus T delta S. Delta H is positive given, delta S is positive given. So you can see at a higher temperature from the equilibrium point, at a higher temperature from equilibrium point, it will be spontaneous. So at a higher temperature, the reaction is spontaneous. So at equilibrium, what do you get? 0 equal to delta H minus T delta S. Therefore, T is equal to delta H by delta S. Delta H given, delta S given, you can get the equilibrium temperature. And at temperature above equilibrium temperature, the reaction will be spontaneous. Because for a reaction to be spontaneous, this has to be negative, right? And this will be negative when this data dominate. And that data dominate beyond a temperature, what do you get here? Hope it is clear. So what is the answer there? You will get temperature greater than 425. So when you work out this, you will get, you see that data, 35.5. That is 35.5 kilojoules into 1000 joules divided by 83.6 joules. You will get 435, 425 something. And a temperature above that, that is option 1. And a temperature above that, you can see the reaction will be spontaneous. I think it is clear. So choice 1, the correct answer. Choice 1, the correct answer. Okay, next question. Fifth question. The bond dissociation energies of X2, Y2 and XY are in the ratio 1:0.5:1. Delta H for the formation of XY given. Bond dissociation energy of X2 will be. Bond dissociation energy of X2 will be. How to calculate? Delta H formation of xy is given. So it is half x2 plus half y2 giving xy. This value is given minus 200. Okay. Now bond dissociation energies x2, y2, xy in the ratio. The bond dissociation energies are in the ratio x2, y2 and xy. It is 1 is to 0.5 is to 1. So suppose the bond dissociation energy, this is x, this is x by 2 and this is x. Okay. Now, in the the bond dissociation energy of x2, x is what we need to find out. We need to find out x, right? Now you apply the equation delta H of reaction is equal to sum of bond enthalpy of reactants minus sum of bond enthalpy of products. What is that? Bond enthalpy of reactants, x kilojoule per mole. For half mole, it is x by 2. X by 2 kilojoule per mole. For half mole, it will be x by 4. This is reactants. Minus that of product, x. And this is equal to minus 200. Find out x. So x by 2 plus x by 4 minus x is equal to minus 200. Find out x. And you can easily work out x as 800 kilojoules. You can easily work out x as 800 kilojoules. That is option 1. Simple calculation. I am not spending the time. Simple calculation. So I'll repeat. Their bond enthalpy in the ratio 1 is to 0.5 is to 1. So if this is x by 2, this is x. Okay. Now, the enthalpy of reaction given minus 200 and that is equal to sum of bond enthalpy of reactants minus that of products taught in the classes. So what do? Sum of that of the reactants, x kilojoule per mole for half mole x by 2. X by 2 kilojoule per mole for half mole x by 4. And you add that and subtract with x, you get minus 200, find out x. Okay. Next question. Sixth one. Under isothermal conditions, a gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure, I believe, from 0.1 liter to against a constant external pressure of 2 bar. Work done by the gas is. So isothermal work done, you know what is the equation? Just substitute in that, you get your answer. Isothermal work done, right? Against an constant external pressure. Against a constant external pressure. So this is work done is equal to minus P external delta V. Pressure given, delta V given, substitute and get your answer in liter bar. Liter bar you get the value 0.3. And how to convert into joules? Into 101.33 or approximately 100. So it is 0.3 into 100, that is minus 30 kilojoule. Option 4 is the correct answer. Everybody know the work done equation P delta V. Substitute and find out. Okay. Next one. Remember, it is given against a constant external pressure, irreversible work done. Aduthathu. For the reaction 2Cl gas giving Cl2 gas, correct option is, you see, 2 chlorine atoms combine. 2 chlorine atom combine to give a chlorine molecule. So a bond is formed. Formation of bond involves releasing of energy. So it is exothermic. Delta H less than 0. Delta H less than 0. So 2 choices out. Okay. Now 2 atoms combine to give 1 particle. 2 particles combine to form 1 particle. What is happening to entropy? two particles combine to make one particle. What happened to entropy? What happened to degree of disorder? Decreases. Degree of disorder decreases. So delta S is also less than 0. And the correct answer is option 3. Simple question. Okay. Option 3. Next one. 1 mole methane undergo combustion to form carbon dioxide and water. Difference between delta H and delta U. You know the relation. Delta H is equal to delta U plus delta nRT. Therefore, delta H minus delta U equal to delta nRT. The point is, what is delta N? That's all. And what is the reaction we are concerned with? What is the reaction we are concerned with? 1 mole methane undergo combustion. So methane undergo combustion. You know methane gas burns with the 2 oxygen gas. You get 1 carbon dioxide gas and you get 2 H2O liquid state as it is 25 degrees Celsius. So what is delta N? Once you get delta N, you get your answer. What is delta N? Delta N is N products minus N reactants. Remember, only for gases. Only for gases. This is the liquid and don't take. Gas, 1 mole. So it is 1 mole minus, both are gases. 2 plus 1, 3. So 1 minus 3, it is minus 2. And the answer is minus 2 RT, option A. Minus 2 RT. See, the point is get to delta N. That's all. Get to delta N. That's all. Next question. Enthalpy of a reaction carried out in bomb calorimeter and in open calorimeter. Bomb calorimeter is an example for closed calorimeter where the volume remains constant. And open calorimeter is pressure remaining constant. So here volume remain constant and here pressure remain constant. So heated constant volume, that is QV, that is delta U. Heated constant pressure, that is QP, that is delta H. Either QV and QP. Option A is the correct answer. Option A. Next one. Silver oxide converted to silver oxygen. Delta H, delta S given. The reaction will not be spontaneous. The reaction will not be spontaneous. Once again, you see, this is positive, this is positive. So, delta H and delta S both are positive. We did a question previously. So, find out the equilibrium temperature. And below that temperature, the reaction is non-spontaneous. You see, Gibbs equation once again. I am just writing. Delta H, delta G is equal to delta H minus T delta S. This is given positive. This is given positive. And the reaction will not be spontaneous. That means this will be positive. This will be positive means this is greater. That means lower temperature. So find out the equilibrium temperature. Find out the equilibrium temperature. Apply delta G equal to 0. You will be getting T is equal to delta H by delta S. Delta H given, delta S given. Find out the equilibrium temperature. Below that temperature, the reaction will not be spontaneous. Above that temperature, the reaction will be spontaneous. Okay? You can easily work out that. You will get a temperature 463 Kelvin. Below 463, that is the answer. Option B. Below 463, the reaction will be non-spontaneous. Above 463, the reaction will be spontaneous. At 463, the reaction is equilibrium. Okay? Next question. A cylinder contains 14 kg butane About 25% of this is wasted. Delta H combustion butane given 2500 kilojoule. A family needed 20 into 10 raised to 6 joule per day. Under these conditions, the cylinder will last for a maximum of how many days? How many days that family will be able to use that fuel maximum? The maximum, that is the question. Okay? Simple one, moderate one, not a tough question. You see, mass of butane used for combustion, how much? The total mass is 14 kg, but 25% is wasted. So how much is utilized? 75%. How much? 75% of 14. That means 10.5 kg. 10.5 kg. Okay? 10.5 kg means this much of gram. This much of gram means this much of mole. Isn't it? That much of moles. So for that much of moles, how much heat will be released? How much heat will be released? The enthalpy of combustion of butane given 2500 kilojoule. This is 2500 kilojoule per mole. Molar mass of butane 58. So for 1 mole, this is the data. For 1 mole, the heat released is 2500. How many moles we have? We have this much of grams divided by 58, number of moles. Okay, therefore total energy produced will be number of moles into 2500 kg. So this is the number of moles. This is the energy available in kilojoules and into 1000 in joules. Now, one day you need this much of joules. One day you need that much of energy. So how many days it will last? The total energy available is this much. One day you need this much. Therefore, number of days will be this divided by that value. You will get approximately 22 days it will last. 22 days it will last. A beautiful question. See, in a cylinder you have 14 kg butane. Okay, how much it is utilized? 25% is wastage. So how much is utilized? 75%. So how much? 75% of 40. How much? 10.5 kg. How many grams? 10,500 gram. How many moles? Mass by molar mass. And how much energy you get? For 1 mole, this is the energy. For this much of moles, this is the energy available. Into 1000, this much joules. Now, one day you need this much joules. Therefore, number of days will be total energy available divided by energy required per day. That will give you the number of days. I think it is clear. Right. Next question. A gas expands from 1 liter to 6 liter against a constant pressure of 1 atm and it absorbs 500 joules of heat. Delta U is, again, first law of thermodynamics, delta U is equal to what? Q plus W. Q given. Data for W given. Work out and find out. First law of thermodynamics, delta U is equal to Q plus W. What is W? P delta V. How much? P into delta V. What is pressure? 1 atm. What is delta V? 1 liter to 6 liter. So delta V will be 5 liters. So it is minus 1 into 5. 5 liter atm into 101.3. That is some 506.5 joules. 506.5 joules. Okay. Now Q given in the question 500 joules. So that is absorbed. This is expansion work. So this is minus, and this is plus. It is absorbed. So Q is plus 500 and this is work done minus, and you take delta U is equal to Q plus W, and here it is W is work done, work of expansion. Work done by the system, work of expansion. So it will be Q plus minus W, Q minus W. So it is 500 minus 506.5. You get minus 6.5 option B as the correct answer. First law of thermodynamics. First law of thermodynamics. Can we go to next? Next question. Substance which has zero value of enthalpy of formation. You have studied elements in their standard state. Elements in their standard state, enthalpy will be zero. Elements in their standard state, enthalpy will be zero. Which is standard state? Which is standard state? Sulfur monoclinic. It is not a standard state. Rhombic sulfur is standard state. White phosphorus is in the standard state. Carbon, graphite is in the standard state. Bromine, liquid bromine is in the standard state. So the answer is option B, white phosphorus. That is thermodynamically stable standard state taken. Thermodynamically stable standard state considered is white phosphorus. Not the usual stability of the phosphorus. White phosphorus is reactive. Not like that. Thermodynamically stable form, elementary form of phosphorus taken is white phosphorus, and that remain the answer. While others are not their standard state, bromine should be in the liquid state, carbon standard state is graphite, and this is rhombic sulfur, all of you know, and the answer is option B. Next question. Of the following equations, correct relations are, this is correct relation, you know, that is correct relation, Gibbs equation. But the choices tell us that there is one more. Anyway, these two, this is not correct, this is not correct, and this is also not correct. So there is something here, something here. Please understand, this is nothing but minus delta S. Delta S is equal to minus d by dt of delta G. Delta S is equal to minus d by dt of delta G. You might have seen somewhere that formula. Okay, so substitute this value, you get this one, minus delta S is equal to, or delta S is equal to minus d by dt of delta G. When you substitute, this equation is correct and this equation is also correct, and the answer must be 1 and 2. Answer must be 1 and 2. You see this? Delta S is equal to minus d by dt of delta G. So substituting in the Gibbs equation, you get option A, 1 and 2. Can we go to next? Next. Carbon plus 4 hydrogen methane, delta H given. 2 carbon, 6 hydrogen, C2H6, delta H given. CC bond energy is, CC bond energy is you see, carbon plus 4 hydrogen methane, you get a delta H minus 360. That means these four bond forming, the data is minus 360. Therefore, 1 carbon hydrogen bond, how much it is? 4 bond, 360. 1 bond, how much it is? It will be minus 360 divided by 4. You get 90. Okay. Now, the second one. 2 carbon, 6 hydrogen, C2H6. That means formation of this molecule, the data is minus 620. That means carbon hydrogen bond 1, 2, 3, 4, 5, 6. 6 carbon hydrogen bond plus 1 carbon bond, that is equal to 620. You see that? 6 carbon hydrogen bond plus 1 carbon bond, that is equal to 620. What we need to find out is, what is carbon bond energy? Simple. This you subtract from this, you get your answer. So the answer will be minus 620 minus how much? minus 90 into 4. Minus 90 into 6. Minus 90 into 6. That you subtract. You get your answer. I repeat. 4 carbon hydrogen bond 360. Therefore, 1 carbon hydrogen bond 90. Coming here. 6 carbon hydrogen bond. 6 carbon hydrogen bond and 1 carbon carbon bond, it is minus 620. So what is 1 carbon carbon bond? It will be 620 minus 6 carbon hydrogen bond. That data will give you the answer. You will get the answer. You will get the answer option B. Option B 80. Option B 80. Here I have put all minus. Here I have put all minus. That is not required, no? Why that is not required? Why that is not required? Because breaking of bond, you have to supply energy, right? So you need not give minus. Breaking of bond, you have to supply energy. So for the formation of 4 carbon hydrogen bond, minus 360. Breaking of 4 carbon hydrogen bond, you need 360. For 1 carbon hydrogen bond, 90. Okay. And the breaking of this entire bond, 620. For 1 carbon hydrogen bond, 90. 6 carbon hydrogen bond, 6 into 90. So it will be 620 equal to 6 into 90 plus carbon carbon bond. So what is this value? So it will be 620 minus 6 into 90. Right? Simple mathematical context. That's all. Can we go to next? Yes. You will get option B as the correct answer. Next one. Heat of formation of water. Heat of formation of water. Which one will represent heat of formation of water? Hydrogen gas, oxygen gas, H2O liquid, 2H2 plus O2 giving 2H2O. Heat of formation is for 1 mole compound. It is not for 2 mole compound. It is for 1 mole compound. So here it is 2 mole out. H2 plus half O2 giving H2O liquid, and this is the answer. What is the problem here? Atomic oxygen not permitted. What is the problem here? You get water, but it is some other reaction. So what is the definition for enthalpy of formation? Enthalpy of formation defined as the heat involved during the formation of 1 mole of a compound from its constituent elements. Okay, next. So the answer is option B. Next, 17th question. Carbon diamond plus oxygen giving CO2 delta H available. Carbon graphite converted to CO2 delta H available. The heat liberated when 1 gram diamond is converted to 1 gram graphite. 1 gram diamond is converted to 1 gram graphite. You see, C diamond converted to C graphite. What is the value? What is the value? Easily you can get from the two equations. C diamond on left hand side, C graphite you need on right hand side. So the data will be minus 398. You take the first equation as such. Now you reverse the second equation and add. So it will be plus 395. Add this. How much it is? How much it is? Minus 3. You get minus 3 kilojoule. So for the conversion of 1 mole diamond to graphite, conversion of 1 mole diamond to graphite, the data is minus 3 kilojoule. 1 mole means 12 gram. The data is this much. Therefore 1 gram, what is the value? It is minus 3 kilojoule divided by 12. Minus 3 kilojoule divided by 12. So it is minus 3000 joule divided by 12 will take you to the answer. Option D. Option D. Sorry, option C. ശരിയല്ലേ? The heat liberated when 1 gram diamond is converted to 1 gram graphite. Yeah, option C only. Option C only. Heat liberated. It is commented heat liberated. Actually, giving like this is creating a confusion. When we say heat liberated, when we say heat absorbed, no need of any sign. No need of any sign. Heat liberated means minus. Heat absorbed means plus. So once it is commented in the question, heat liberated, heat absorbed, no need of any further sign. Sign is not required. Simply data is required. So giving such a data will create a confusion. It is given heat liberated. So perfect answer option C. When we say heat liberated, no need of any sign. Actually it is minus. Actually it is minus. Hope you understand. Once again, C diamond converted to C graphite. That you find out first. So you take first equation as such. That means first data as such. Now you reverse the second equation so that graphite comes on the right hand side. Now add. Reversing means this data will become positive. So it is minus 398 plus 395. Add the 2. You get minus 3 kilojoule. That is for 1 mole. That is 12 gram. For 1 gram they are asking. So it is minus 3 kilojoule, that is minus 3000 joule divided by 12. So you will get minus 250. But the answer is 250. Why? In the question itself it is commented heat liberated. No need of any sign. Next one. Amount of heat liberated when 200 ml 0.3 molar sulfuric acid mixed with 300 ml 0.5 molar NaOH. 200 ml 0.3 molar sulfuric acid mixed with 300 ml 0.5 molar NaOH. You see that 300 ml 200 ml 0.3 molar sulfuric acid. That means 120 milli equivalent. How to get a milli equivalence? How to get a milli equivalence? Normality into volume in milliliter. What is normality? What is normality? 2 times molarity. 2 times molarity because it is a dibasic acid into volume in milliliter. That is 2 into how much? 2 into 0.3 into 200. 2 into 0.3 into 200. This is actually not required. 120 milli equivalent. That is sulfuric acid. 2 into 0.3 into 200. 120 milli equivalents. Now what about NaOH? NaOH. Once again, it is normality into volume in liter. But NaOH is a monoacidic base. Monoacidic base, molarity and normality are same. So it is normality 0.5, volume in milliliter 300 ml. That is the milli equivalence. It is 150. 0.5 into 300. It is 150. Those thousands are not required. So this is 120 and this is 150. So this is the limiting reactant. Sulfuric acid is the limiting reactant. And that will decide the completion of the reaction and that will decide the heat liberated. You must know one equivalent of acid when completely neutralized. One equivalent of strong acid or strong base when completely neutralized. The heat liberated is 57.2, 50.7, 57.3 kilojoule per equivalent. That is the data. For one equivalent, this is the data. Here it is 120 milli equivalents. So what is the data? What is the heat liberated? For one equivalent, the heat liberated is 57.2. Limiting reactor 57.2 for one equivalent. Therefore, 120 milli equivalents. 120 milli equivalent means 120 into 1000 equivalent. 120 divided by 1000 equivalents. So 120 by 1000 equivalents into 52.7, you will get the answer 6.86 kilojoule. Option A, the D. Any strong acid, strong base, when neutralized, the heat liberated is invariably constant. Because whether it is sulfuric acid NaOH, whether it is HCl NaOH, whether it is HCl KOH, fundamentally the reaction is same, formation of water. And therefore the enthalpy of neutralization of the reaction is constant. 57.3 kilojoule per equivalent or 13.7 kilocalorie per equivalent. That data is fixed. You must know that data. So for one equivalent neutralization, the energy is 57.3 or 57.2 something. Here, 120 milli equivalent of sulfuric acid and 150 milli equivalent of acid is base is reacting. So this is the limiting reactant, and that will decide the amount of completion of the reaction. That means amount of heat liberated. So for one equivalent, the heat released is 57.2. Therefore, 120 milli equivalent, that is 0.12 equivalent. How much is the value? So 57.2 into 0.12. That is the answer. Okay. You will get option D. Next question. Enthalpy of formation of NaF given. Enthalpy of sublimation of sodium given. Ionization enthalpy in the gaseous state given. Bond enthalpy of fluorine given. Electron gain enthalpy of fluorine given. Lattice enthalpy. How much lattice enthalpy? That is the question. Apply Born-Haber cycle. Apply Born-Haber cycle. Na solid plus half F2 gas. You are getting NaF solid. This data is given. How much? Minus 400. This data is given. And now, this is converted to Na gas. That data is given. How much? 100. This data is given. 100. Pinne. Ionization enthalpy given. This is converted to Na plus gas. That data is given. 500. Now, bond enthalpy of fluorine. This data is given. This is converted to F gas. This data is given. 200. It is actually 200 by 2. For 1 mole 200, half mole 200 by 2. Pinne. Electron gain enthalpy of fluorine. This is converted to F minus gas. The data is given. Minus 300. Now, these two interact, giving this. What is this data? That is a question. Very simple, no? This plus this plus this plus this plus x equal to this. Find out what is x. This plus this plus this plus this plus this equal to this. Find out what is x. But remember, this is lattice enthalpy of formation. What is asked for? Lattice enthalpy. Lattice enthalpy will be always endothermic. Lattice enthalpy means amount of energy required to break the lattice. The question asked is, what is the data? What is the data for this? You are getting a data this. Probably you will get a minus value and the answer will be plus value. That's all. No minus value given, only plus value. So entire data given, you have to just equate. The total enthalpy is equal to Hess's law. Born-Haber cycle, Hess's law. The total enthalpy is equal to enthalpy of individual steps. What are the individual steps? 1 plus 2 plus 3 plus 4 plus 5. So this plus this plus this plus this plus this. You get this. What is this value? Upon calculating, you will get x with a minus sign. because that is enthalpy of formation. What we want is enthalpy. Enthalpy of lattice enthalpy of formation. What asked is lattice enthalpy. Lattice enthalpy means what amount of energy required to break the lattice. So just remove that minus sign and report your answer. And the answer will be option 800. You will get it as option D, 800. Okay. You see that the total enthalpy is equal to that those values I have commented, 100 plus 500 plus 200 by 2 plus minus 300 plus minus lattice enthalpy. Next. Delta H fusion of ice is equal to 6 kilojoule per mole. Entropy change for the conversion of 1 mole ice into water at 0 degrees Celsius, 1 atm pressure is. So delta H given, you are asked to identify delta S. Delta S is equal to delta H by T. Delta S is equal to delta H by T at equilibrium. This is at equilibrium. So delta S is equal to delta H by T. Delta H given, T is given. You find out option C. Next question. 2 mole ideal gas 27 degrees Celsius expands reversibly from 2 to 20 liter. Entropy change. Similar question we did already. Delta S is not the question. We discussed the formula. Yes. Delta S is equal to 2.303 NR log V final by V initial. We have discussed. You see 2 mole gas. So this is 2 mole. R value in calorie. Entropy change in calorie. R value is 2 in calorie. And log V2, V1. What is V2, V1? 20 and 2. So this is 20 and this is 2. That means log 20 by 2. That is log 10. Log 10 is 1. So the answer will be 2.303 into 4. 2.303 into 2. That is 4.6 into 2. 9.2. Option D. Can I go to next? Next question. The relation between delta G and the reaction quotient is one equation given in the NCERT. Delta G is equal to delta G naught plus RT log Q. Delta G is equal to delta G naught plus RT log Q. And at equilibrium, this will become 0. So you get at equilibrium, what do you get? 0 equal to delta G naught plus RT log K. And therefore, the very famous equation you are familiar with, delta G is equal to minus RT log K. This equation comes from that context. Next one. Option A. The value of delta H solution of barium chloride solid and barium chloride 2 hydrate solid are A and B given. So value of delta H solution of this and this given A and B. What to find out? The value of delta H hydration of barium chloride is. Value of delta H hydration of barium chloride is. Another question from the application of Hess's law. Application of Hess's law. You see that this converted to solution A kilojoule. This converted to solution B kilojoule. What is this? That is a question. So this is one step operation and this is two step operation. So the overall A is equal to this plus this. See, this is one step reaction. This is two step process. Step 1, step 2. So overall enthalpy is equal to enthalpy of step 1 plus step 2. So this plus this is equal to this. So this plus B is equal to A. Therefore this is equal to A minus B. A minus B. Simple application of Hess's law. Next question. When 20 ml strong acid added to 20 ml alkali, the temperature rises by 5 degrees Celsius. If 200 ml each of the solution are mixed, the temperature rise would be, right? You see, 20 ml strong acid, 20 ml alkali added. The temperature rise is 5 degrees Celsius. Now we are taking 200 ml each. That means 10 times. So when you take 10 times, the heat released will be 10 times. Okay. So in the first case, if the heat released is X, second case, the heat released is 10 times, 10x. Suppose I am taking 20 ml each. Suppose I am taking 20 ml each, first case. 20 plus 20 ml. Imagine the heat released is X kilojoule. Now the second case, I am taking 200 ml each. 200 ml each. The heat released is 10x kilojoule. But you know, the rise in temperature will be same. Why? Because here x kilojoule and the total volume is 20 plus 20, 40 ml matter. Total volume is 40 ml matter. So x kilojoule, 40 ml matter, rise in temperature is 5 degrees Celsius. Now 10x kilojoule, the total matter is 400 ml. You see, heat becomes 10 times, but the quantity also becomes 10 times. Therefore, the rise in temperature will be same in both the cases. Because all of you know, Q is equal to mc delta T. Q is equal to mc delta T. You see, this rises by 10 times, agreed. The heat rises by 10 times, agreed. But the mass is also rising 10 times. Therefore, delta T will remain constant. This is already a constant. So, rise in temperature will remain constant. So, case 1, 20 plus 20, 40 ml. Heat released X, rise in temperature 5 degree. Second case, 200 ml, 200 ml, 10 times. The heat released is 10x. But the rise in temperature remained the same because the quantity of matter is also 10 times. Hope you understand. Yes. Excellent question. Next. Delta H combustion of benzene, carbon, hydrogen given. Hence, heat of formation of benzene is heat of formation of benzene. It is carbon, solid, plus hydrogen, gas, you get benzene. You get benzene, liquid state. Okay. So there must be 6 carbon and there must be 3 H2 to get benzene. What all data given? Enthalpy of combustion data given. Delta H combustion data given. How much? Benzene minus 3000. Carbon minus 390. Hydrogen minus 290. The point is, what is delta H? What is delta H? That is the point. Simple. Delta H reaction is equal to sum of enthalpy combustion of reactants minus sum of enthalpy combustion of products. So that will be minus 390 into 6 plus minus 290 into 3. The whole minus 3000. That will give you the answer. So enthalpy of reaction, we want to find enthalpy of formation of benzene. This is enthalpy, this is the formation of benzene reaction. What is the enthalpy they are asking? What's given? Enthalpy of combustion of carbon minus 390 kilojoule per mole for 6 mole into 6. Minus 290 kilojoule per mole for 3 mole into 3. Minus 3000 kilojoule per mole. Enthalpy of reaction is equal to sum of enthalpy combustion of reactants minus sum of enthalpy combustion of products. Substitute and find out the answer to be option C. Option C, minus 210. Option C, minus 210, whether you get or not. Very fine. Okay. Next question. Twenty-sixth question. Sulfur plus half O2 SO3 2x plus 2x. SO2 plus half O2 SO3 minus 5 kilocalorie. Enthalpy of formation of SO2. Enthalpy of formation of SO2 means S plus O2 giving SO2. This is what you need to find out. So you want sulfur on left hand side, sulfur on left hand side. So you take first equation as such. You want SO2 right hand side, you take the second equation reverse. Reverse the second equation and take. 2 dash means reverse of the second equation. Take the reverse of second equation. So for the first equation, S plus O2 giving SO3 plus 2x, therefore delta H is minus 2x. You see that? S plus half O2 giving SO3 plus 2x. That means product plus heat. That means it is exothermic, minus 2x. So you can write like this. S plus half O2 giving SO3. Delta H will be minus 2x. You take this equation as such. Now, second equation. SO2 plus half O2 giving SO3. Delta H is minus Y. See, when you write the heat along with the product, if it is written plus, what's that meaning? The product plus heat, that means it is exothermic. The product SO3 plus heat, that means that is exothermic, right? So what you need to do is, if you want to get this equation, take the first equation as such. That means minus 2x. Add with the reverse of second equation. You reverse this equation. That means y will become plus y. Now add. So minus 2x plus y. That is y minus 2x. That is the answer. Y minus 2x. Option A is the correct answer. Option A is the correct answer. Hope it is clear. You see that S plus half O2 giving SO3, delta H is minus 2x. SO3 giving SO2 plus half O2, delta H plus y. That means the reverse of the second equation. The reverse of the second equation. And you will get, adding the two, you will get the answer. X1. Arthust. The enthalpy change for hydrogenation of ethane. If bond energies of carbon, hydrogen, carbon, carbon, single bond, double bond and HH are respectively. Enthalpy change for hydrogenation of ethane. It should not be ethane. Ethane cannot be hydrogenated. It must be ethene, children. It must be ethene. It must be ethene. So we want to find the enthalpy change for hydrogenation of ethene. Enthalpy change for hydrogenation of ethene. Yes, exactly. Ethene plus hydrogen, you get ethane. Ethene plus hydrogen, you get ethane. You can apply that equation. Delta H is equal to sum of bond energy of reactant minus that of product. Sum of bond energy of reactants minus that of product. What is reactant? This one and this one. So which all data? Carbon, carbon, this data. You take this data plus CH data. CH data how much? There are 2 plus 2. You see, ethene. This is ethene. So you need CH data 4 times plus CC double bond data 1 plus HH data, that is 2670. That is 2670. And now what is on the product side? What is on the product side? CH3, C, CH3, isn't it? So CH data 6 times and CC data 1 times, and that sum value is 2810. So bond energy of reactants minus products. Already we have seen that equation 2-3 times. So what is reactants? This one. How much value? CH value 1, 2, 3, 4. Where is CH value? First value. So this into 4 take. Now CC double bond. CC double bond, third value 600. So this into 4 plus 600. That is, sorry, one more. HH value also. HH value also. What is HH value? This one. So this into 4 plus this is the data 2670. Now what is on the product side? Product side is CH value 3 plus 3, 6. So this value into 6 plus CC value, this value. That is on the product side. That is 2810. So when you subtract, you get your answer option A, minus 140. Enthalpy of reaction is equal to sum of enthalpy of reactants sum of bond enthalpies of reactants minus products. Okay, next. Enthalpy change for the reaction given. Enthalpy of formation of ammonia in kilojoule per mole. You see, decomposition value is 92. Therefore, formation value will be minus 92. The reverse reaction, N2 plus 3H2 giving 2NH3 will be minus 92. That is for 2 mole ammonia. So for 1 mole ammonia, it will be minus 46. Option B. The given equation is decomposition of ammonia. So for formation of ammonia, minus. That is for 2 mole. So for 1 mole by 2. Next. The salt which is likely to cause maximum cooling when 1 mole of it is dissolved in the same volume of water is maximum cooling. Maximum cooling means you get a cooling effect in endothermic reaction. In endothermic reaction, heat is absorbed. So heat absorbed means, suppose you are touching, heat absorbed means you get a cooling effect. When you get a cooling effect, when the heat is absorbed from the surrounding, that is endothermic process. So higher the endothermic character, higher the cooling effect. Option B. This is absorbing maximum heat during the reaction, and that creates a cooling effect. Option B. Next. Where delta H is equal to delta U. Parnadana. Delta H is equal to delta U plus delta nRT. So when delta N is equal to 0, these two will be equal. Delta N when becomes 0, that two will be equal. First choice, delta N is 0, 2 minus 2, 0. The first choice itself, delta N is equal to 0. Right? And there, delta H is equal to delta U. Fine? Yes. Option A. That was the last question in that chapter. Of course, quite good number of numericals are involved in the chapter. A very important chapter. 1 or 2 questions generally you can expect from this chapter. Right? Okay, so we will meet in another discussion, another chapter. Bye. See you.